Imagine a reality where everything we know, everything we are, hangs by a thread, a delicate thread that could snap at any moment, plunging us into the unknown. A universe teetering on the brink of annihilation, its very fabric susceptible to a catastrophic unraveling. The cosmos, as we perceive it, is a fragile tapestry woven with the threads of fundamental forces. This is not science fiction, it is a stark reality that scientists grapple with every day. This is the chilling possibility presented by the concept of false vacuum decay, a phenomenon that could redefine our understanding of the universe. Our universe, in all its vastness and complexity, exists in a particular energy state. This state, while seemingly stable, is precarious. Like a ball resting in a valley, this state represents a point of stability, but this stability is not absolute. But what if this stability is an illusion? What if the ball is not in the true valley but merely balanced on a precarious ledge? What if our universe is not nestled in the true valley, but perched precariously on a ledge, separated from a deeper, more stable abyss by an insurmountable wall? This wall represents the energy barrier that keeps us in our current state. This, in essence, is the idea of a false vacuum. A false vacuum is a metastable state, one that appears stable but is not the lowest energy state possible. We might be living in a temporary state of equilibrium, a cosmic illusion that could shatter at any moment, sending our universe tumbling into the abyss of true vacuum. The true vacuum represents the lowest possible energy state. The trigger for this catastrophic event, it could be a quantum fluctuation, a tiny event with monumental consequences, a quantum event known as false vacuum decay. This decay could initiate a chain reaction, altering the very fabric of our universe. This is not mere theoretical speculation. It is a hypothesis grounded in the principles of quantum mechanics and particle physics. In the heart of a laboratory, physicists have begun to simulate the very forces that could drive this cosmic unraveling, offering us a glimpse into the potential end of everything. These simulations help us understand the delicate balance that sustains our universe and the potential threats that could disrupt it. Imagine a glass of champagne, effervescent and bubbly. The bubbles rise gracefully, each one a tiny universe in itself, full of potential and energy. The champagne itself represents the universe's lowest energy state, the true vacuum. This is the most stable state, where everything is in perfect balance. Now imagine a tiny bubble trapped within the champagne, a region of slightly higher energy. This bubble is not just a simple imperfection, it holds within it the seeds of potential chaos. This bubble is our false vacuum, a metastable state that appears stable but possesses the potential for catastrophic collapse. It's like a ticking time bomb waiting for the right moment to unleash its energy. This precarious balance is maintained by a high-energy barrier that separates the false vacuum from the true vacuum. Think of it as a protective wall, keeping the chaos at bay. Think of it as the wall of the champagne flute, preventing the bubble from merging with the surrounding liquid. This wall is strong, but not impenetrable. However, quantum mechanics, the strange and counterintuitive laws governing the subatomic world, introduces a terrifying possibility: quantum tunneling. This phenomenon defies our everyday understanding of physics. Just as a particle can inexplicably pass through an impenetrable barrier, so too can our universe tunnel through the energy barrier, separating it from the true vacuum. This is not just a theoretical concept, it's a real possibility. This tunneling event, known as false vacuum decay, would be catastrophic. It would be an event of unimaginable scale, altering the very fabric of our universe. What would this decay look like? Imagine the bubble in our champagne suddenly bursting, the high-energy state collapsing into the lower energy state. The transition would be violent and unstoppable. Imagine the bubble in our champagne suddenly bursting, the high-energy state collapsing into the lower energy state. The energy released would be immense, reshaping everything in its vicinity. Now imagine this process occurring at the speed of light, engulfing everything in its path and irrevocably changing the very fabric of existence. The shockwave would spread, consuming galaxies, stars and planets in an instant. This is the potential doomsday scenario presented by false vacuum decay. It's a reminder of the delicate balance that holds our universe together, and the ever-present possibility of its sudden and dramatic end. In 2023, a team of physicists at the University of Leeds made a groundbreaking discovery. Using a highly controlled quantum system, they were able to simulate the dynamics of false vacuum decay. This phenomenon, long theorized but never before observed in such a controlled setting, the universe in their experiment was a carefully calibrated collection of atoms, trapped and manipulated with lasers. These lasers, precise and powerful, allowed the researchers to control the atomic interactions with unprecedented accuracy. These atoms, chilled to near absolute zero, were in a state of minimal energy, making them ideal for such delicate experiments. They were coaxed into a state mimicking the precarious balance of a false vacuum. This state, a delicate equilibrium, was the key to their groundbreaking work. Then, with a flick of their lasers, the researchers nudged their miniature universe, watching as it teetered on the precipice of collapse. This moment was critical, as it demonstrated the fragility of the false vacuum state. What they witnessed was both fascinating and terrifying. The controlled environment allowed them to observe the decay process in real time. The simulated universe, initially stable, rapidly transitioned into a chaotic state as the false vacuum decayed. This transition was marked by a sudden and violent rearrangement of atomic structures. The once ordered arrangement of atoms dissolved into a turbulent mess, mimicking the cosmic unraveling predicted by theoretical physicists. This observation provided a rare glimpse into the potential instability of our own universe. The implications of their findings were profound. While confined to the microscopic world of their experiment, the implications of their findings were far-reaching, offering a chilling glimpse into the potential fate of our own universe. This experiment not only advanced our understanding of quantum mechanics, but also raised new questions about the stability of the cosmos. While confined to the microscopic world of their experiment, the implications of their findings were far-reaching, offering a chilling glimpse into the potential fate of our own universe. Section 4. Simulating the Unthinkable. The Leeds experiment wasn't about recreating a universe-ending event in the lab. Instead, it was about understanding the fundamental physics governing such an event. By carefully controlling and manipulating their atomic system, the researchers could study the dynamics of false vacuum decay in unprecedented detail. Their findings were startling. The simulated collapse was not a gradual process, but a sudden, violent event. Imagine a house of cards collapsing under the slightest breeze. That's how quickly and completely the simulated universe unraveled. More importantly, the experiment confirmed that false vacuum decay could be triggered by a minuscule quantum fluctuation. Just as a single snowflake can trigger an avalanche, a tiny quantum event could potentially plunge our universe into chaos. This realization underscored the delicate nature of our existence, highlighting the fact that even the seemingly stable could be susceptible to sudden and catastrophic change. Section 5. The unfathomable speed of doom. Perhaps the most terrifying aspect of false vacuum decay is its speed. Should our universe succumb to this quantum unraveling, the transition to a true vacuum would propagate at the speed of light. To put it simply, we wouldn't see it coming. Imagine a wave of annihilation originating from a single point and expanding outwards, consuming everything in its path. Stars would blink out of existence, planets would disintegrate, and the very laws of physics as we know them would be rewritten. This is not a gradual process like the slow heat death of the universe or the collision of galaxies. This is an instantaneous, irreversible event that would leave nothing untouched. The universe as we know it would cease to exist, replaced by something entirely different, governed by new laws of physics that we can barely begin to comprehend. Section 6. The odds of our cosmic unraveling. Now, the question that undoubtedly lingers in your mind: how likely is it that our universe will succumb to false vacuum decay? The answer, like much in the realm of quantum physics, is frustratingly uncertain. The truth is, we don't know the exact energy state of our universe, nor do we fully understand the intricacies of the quantum processes that could trigger a decay event. Some theoretical calculations suggest that the lifetime of our universe in its current state could be extraordinarily long, far exceeding the current age of the cosmos. Other calculations, however, offer a less reassuring outlook, suggesting that the possibility of decay, while small, is not insignificant. It's like playing cosmic roulette with a gun that has a single bullet but an unknown number of chambers. We simply don't know if or when the hammer will fall.